You're listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson from Protean Machining, and this week I'm joined by Chris Purceski of Part Shop Max and co-driver at Lamont Motorsports. Welcome, Chris.
How's it going, Dylan? Thanks a lot for having me on the show, man. I appreciate it.
Yeah, thanks for coming on. I appreciate you taking the time. So where can people find you online, if they want to follow along and kind of see what you're talking about?
I'm predominantly on Instagram, so Instagram name is just @CadChris. CHRIS, Chris. And yeah, that's pretty much it. I try to stay as active as possible on there. I'm pretty busy between my job and then side work that I have going on all the time. I kind of struggle a little to post some of the content, but if you ever catch my stories, I'm always on there. I'm pretty live on the stories. So yeah.
Awesome. So let's get into your backstory. How did you get, because right now you are designer and machinist, and it seems like everything under the sun at Part Shop Max. So how did you get to where you are and get the experience you have?
Yeah, for sure. So I don't know if we take it way back, then growing up as a kid, my parents immigrated here from Yugoslavia. I was born about a month after my parents came to this country. So they went through the struggles of moving to a new place, new language, everything like that. And my dad worked construction jobs and then just started his own little business doing remodeling and stuff like that. So I grew up as a kid just constantly going to work sites with them and watching them lay tile, build all sorts of things. And I just remember as a kid just going down to Office Depot and then him buying graph paper and all the fine detail pens and everything, and just always kind of drafting out some of his work with measurements and everything like that. And I'd be sitting right next to him, kind of doing the same thing with my scribbles and stuff. And I think it kind of all started there when I look back on it. And then I was just always a curious kid, just wanting to see how things work, opening things and never being able to put them back together. And growing up with Legos, building things. And then once I got into high school, I took a woodshop class. We had an automotive class. I didn't take it, but we didn't have a metal class, which I was kind of bummed about. That's one thing that always intrigued me is fabrication. So I took woodshop. I was pretty familiar with all the woodworking tools already, just doing stuff with my dad growing up, the construction side of things. So once I got into woodshop, the teacher took a liking to me. I kind of realized that I had enough experience with all the tooling and everything. So he kind of just let me do what I wanted to do, to work on my own projects when the rest of the class kind of had their set projects that they had to make to follow the curriculum. So yeah, it was pretty fun. I was enjoying it. And then my second year of woodshop, he came to me and asked me if I wanted a job. Haven't had a job yet, other than working the summers or whatever. So I'm like, all right, my first job. It was my senior year of high school, probably halfway through it. And so I went ahead and took it, and it was a robotics company. And they specialized in newsroom automation. So
Cool.
back in the day, 80s, 90s, everything was handheld cameras on tripods and dollies and stuff like that. And then a lot of that camera equipment stayed. So really big teleprompters and lenses and full camera packages weighing like 120 pounds. Well, they wanted to start getting into automation because news stations in that side of media had to start cutting costs because of competition with internet and things like that. So one way of doing that was by getting rid of camera operators. So instead of having an operator per camera, now they can have a control room with one or two operators that can control multiple studios of multiple cameras on there with robotic pedestals that had pan and tilt heads, Z columns, and then drive wheels. So you could literally drive them around the entire floor. You can program shots, things like that. So I was really intrigued by that. So I went ahead and got into that. And I started off from the bottom, so sweeping up the shop, cleaning around. And then my main position was pretty much assembly. So you learn how to put together all the subcomponents, sub-assemblies to the pan and tilt heads, the Z columns. They're built just like a CNC machine, obviously. Linear guides, ball screws, everything was high precision, anti-backlash and everything, because you have so much weight with the camera setup that's hanging off and a lot of leverage on that. And the one thing you don't want in studios is obviously a camera shot just kind of vibrating or moving around. So I got to learn how to put together these high-end components. And then we had a Bridgeport and a hard-hinge lathe there. And I was kind of interested in it at the time. And my boss he was actually a machinist from New York. And He started showing me on my free time how to run the machines, and then I think like after the first day or two of him showing me, I got hooked. So I started looking around for ROP classes, and I found that a local high school in the city that I live in, not the high school I went to, had a metal shop. So I signed up for that, and then ended up learning my way around just a knee mill and lathes and doing a lot of manual stuff. Kind of reminded me about the wood shop thing. Teacher was like, okay, you know how to work the machines, just go ahead and do whatever you want. So I did that for like, I think for how long was it? 3 or 4 years. I went every Monday for 3 to 4 hours. Yes, from like 6 to 9, 6 to 10 o'clock at night, after work. So I did that for a really long time and just kept working on all my own projects, got really familiar with that kind of stuff. And they had a Tormach lathe and mill in the office. They were really small ones, CNCs, sorry. And it was interesting. It always piqued my eye, and nobody knew how to run them, not even the teacher. So they were donated to the school, but nobody knew how to set them up or do anything. And then I asked him about it, and he's like, "There's a manual over there if you want to read it." But I knew nothing about CAM or anything, and it just was way over my head. I think I sat down on the computer one time and like fired up whatever CAM software was on there, and then I had no idea what I was doing. So I was like, yeah, you know what? I'm just going to forget about this. So I just stuck with the manual stuff and with the hopes of maybe one day getting into CNC. And then in the meantime, as far as the job goes, I worked at that robotics company for about 3 years. And then I left there and worked at Magnum Off-Road as a CAD designer. So
So were you
actually,
always like a person into cars, a gearhead, or
definitely interested in motorsports for sure. Cars is kind of new to me right now, more so off-road, Southern
okay,
California. We grew up going to the desert, things like
right?
that. So if I go back a bit, when I was working at the robotics place, we were assembling everything with just stacks of blueprints, right? That's how you learn the assembly process. And then it was pretty interesting just looking at the tolerancing of everything. We got to see not only the assembly prints, but the individual prints per part for every component that was machined that went into that. So I was kind of interested in making my own prints and maybe getting into the design side. So once I graduated high school, I went to a local community college, and they had a really good CAD program. They did not have a machining program at the time. So I saw that they had Solidworks, which I heard was somewhat the industry standard. So I wanted to get into that, but the prerequisite was AutoCAD. So started with AutoCAD, 2D stuff, got into the 3D. As soon as I finished those classes and I could move on to SolidWorks, I went right for it while doing my general ed classes. And I think it took about 3 years of SolidWorks. And then in the meantime, the pace with the classes are very slow. And I understand they have a curriculum and stuff, and they don't want to force feed so much information down your throat that you don't retain it. And I get it, but I was just a little more advanced than that. So on the side, I tried to take on as many projects as I could. I started putting up ads on Craigslist for side work, for freelance work, and just kind of built my experience there, just putting in hours and hours. I probably made no money. I mean, every time I got paid, if I billed at that time like $40 an hour, it was probably taking me 5 times as long as it should. But
Right.
whatever, it was just getting the experience. So did that for a while, and then one of my relatives owns Magnum Off-Road where I worked. So he reached out to me and asked me if I could help him with a suspension issue they were having for a Yamaha Rhino long travel kit at the time. So that was back in like oh '08, '09, something like that. And so I went in there and sat down for a couple hours, kind of modeled up the suspension system that they had, and then I started trying to correct some camber gain issues that they were getting. They wanted to reduce that. So we were playing around with geometry points, and then I think they saw the value in all of this. So nothing really came of it for a while. I did that job for them, and then I went back to work, and then I just started getting a little fed up with the robotics company that I was working at, and I was just kind of ready to leave. And then I was talking to that relative friend, and he's like, "Well, would you be open to coming and working for me?" And I was like, "Yeah." It was a new position. Obviously, they've never had a CAD guy. They're a fabrication shop, doing everything very manually, tube notching by hand, everything like that, fabricating all of it done by hand. So we started a new position there, which was weird. You go through these times of what do I work on? What do I do? It's just there's not like a lineup of work for that position yet. So I stayed busy in the back of the shop, whether it's cleaning the shop or just helping some of the fabricators or things like that. We did a lot of, at that time, early on, H1 Hummer Duramax diesel conversions. So I helped a little bit with that, just doing the grunt work around. And so that ended up progressing. I ended up staying at Magnum Off-Road for 8 years. So once I was maybe halfway into that term, we started realizing, that the CAD way is really the only way to go when it comes to the manufacturing side of things. If we wanted to stop doing onesie, twosie projects and stuff and start getting into production work. So we really vamped up the CAD side, started designing everything in the computer, and then started outsourcing tube laser, press brake work for sheet metal, and then just getting familiar with all of those processes as far as the tolerances that those types of shops can hold, what to design the parts at with when it comes to sheet metal, what radius dies you're using for whatever thicknesses and whatever grade materials. So once we kind of got into that, we started getting a little deeper. We designed a full tube chassis in CAD on a fixture table, designed it all on the computer first, then ordered that all up, and then made a run of 5 chassis, race chassis, full chrome ollie and everything. And it's funny because we just did it on our own. We just learned as we went. We didn't have like some old time experienced guy there showing you the ropes. We just kind of did it with the technology and everything. And at that time, we didn't own anything like a 3D scanner or obviously any kind of CNC equipment or anything like that. So we outsourced everything and got to go to these shops that were doing this work for us and seeing the process, seeing the details, seeing what's involved and everything. And then towards the last maybe 6 months of my time at Magnum Off-Road, we purchased our first Ferro Arm, our 3D scanner from Andrew McEwen, who you had on your show. Andrew's a good guy.
Yeah, he definitely is.
Yeah, he came by, demoed the arm, and quickly realized what we could do with it and how it could help our process. So we went ahead and purchased one of those. And then I just started getting familiar with it and started scanning our first few things, projects that we were working on. And then I got a good opportunity that came my way with Part Shop Max. And I think I just wanted some change, wanted something new, try something else, and maybe get out of the off-road sector. I was a bit burned out on it. Working with a bunch of guys in off-road and going to the desert every desert season, it's fun and we had some great times, but eventually you just get burned out. So I decided it was some good time for change. So I took the Part Shop Max deal, and yeah, I mean, we're located here in North County, San Diego. As far as Part Shop Max goes, history on that, the company's been around for about 15 years, I believe. And then we specialize in drift suspension and design and manufacture just high steering angle kits for cars to pretty much slide sideways. We don't only focus on the suspension side of things. We also make accessory items for the vehicles as well, shift knobs, handbrakes, handbrake handles, things like that, dual caliper brackets for those things, obviously all drift related. Anything that can pretty much make the drifting experience better or reinforce the chassis or the vehicles themselves. Obviously, when you're throwing these things sideways, they're not designed for it. So things like to break, the chassis don't like to hold up. So
When you guys have just started doing body panels too, right?
yeah, so I'll get into that in a minute. So as far as Part Shop Max goes, we're located worldwide. Our facility in North America it covers North America and is pretty much HQ. So we design everything here. We own a factory in Taiwan. The factory pretty much outsources everything we design as far as the machining. Welding was done in-house. We started outsourcing some of the we designed the fixtures at our factory and actually produce those there for all of our suspension weldments. And they outsource the coatings and everything. And a lot of people don't realize how many things we actually manufacture. When we break down the suspension components, I mean, our number one selling products are coilovers. We make our own coilovers from scratch. Yeah, the body design, the needle design, the internals, everything is all custom. The bearings, the spherical bearings that go into our suspension systems, we have those bearings custom made for us for a certain breakaway torque. When you come from off-road, all of those spherical bearings and rod ends are very tight when they're brand new. They're very stiff because the second you go do an off-road race with them, I mean, they're going to break in and get pretty sloppy. On the drift side, it's actually the opposite. We don't start out with things that are very stiff because we want the car to be able to snap back on its own. So we try to take away some of that breakaway torque and make the bearings, I don't want to say a sloppier fit. They're not a sloppier fit. They're nice and
Consistent.
tight, but consistent and much freer. And then, yeah, we do forgings, castings. All of our most of our products are packaged there in Taiwan as well, and then shipped to us. So us being the North America hub, we inventory a lot of parts, pallet racks and everything like that. The items are in boxes of foam, everything. Products are painted, coated, powder coated, just ready to go to the customer, anodized, everything. All of the misalignment bearings, everything's in there, ready to go. And then we started manufacturing some things here in the States as well. So I'm sure you've noticed that we've got the welding robot, the OTC welding robot.
Yeah, we got a lot of questions about that.
Yeah, we did. Yeah, for sure. So as far as the manufacturing side of Part Shaw Max goes, I would say that 80% of it's manufactured in Taiwan. The other 20% is manufactured here. And the robot came into play with, we started to make strut tower braces for the fronts and rears of vehicles.
Okay.
And those are obviously weldments. And we're trying to tie the coilover towers right to each other and strengthen it all up. So when we get into the weldment stuff, our facility in Taiwan is already so overwhelmed with the amount of new designs that we're sending to them. And at any given time, they're using multiple welding shops, multiple machine shops, coders, everything like that. So we wanted to free up their workload and start manufacturing some of it here. And obviously we get some incentives to spend some money on equipment here, right? So the first big purchase was the OTC robot, and we figured we'll just go ahead and start doing all the weldments of those items here by utilizing the 3D tube laser, press brake work that we get done around here, which is all really high precision stuff. But when we look back in Taiwan, they have the capability to have these types of equipments, but they do have a different way of thinking. Like when we ask our facility in Taiwan, like, hey, why don't you guys start making these tubes that comprise of that pretty much make up some of our suspension arms? Why don't you start making these on a 3D tube laser? They like to do things really manual. They'll make a punching die and start punching the copes and notches out of the ends of tubes with a press, which is very archaic to us with all the new technology.
Oh, yeah.
So where was I going with that?
Well, it seems like you guys are using a similar philosophy to the robotics company you worked for. Rather than throwing people at it, you're throwing technology at the problem and coming up so that you can still manufacture here and all that, which is pretty cool.
Yeah, right. Oh, and the other thing was when I came on at Part Shop Max, my boss had previously purchased some Artec 3D scanners, which are just the photogrammetry style 3D scanner. So I came from using a Faro into a shop using the Artec scanners, picked up that pretty quickly. And then we found some downfalls with the equipment that we had. We were kind of working outside of its work envelope. So scanning things that are bigger than what it's designed for. We use many targets and stuff. I don't know if you're familiar with the photogrammetry stuff, but you really got to put these stickers and targets and recognition marks everywhere so that the tracking kind of follows seamlessly. But that didn't end up happening. We ended up getting twisted designs that you somewhat couldn't tell. They were ever so slightly twisted, the 3D scans. So we went into manufacturing some of these braces, and they weren't fitting the vehicles. So as soon as we found out that we were having that issue, yeah, we just decided, you know what, let's just go with the equipment that we know works. I reached out to Andrew again and got him to come over to the shop, demo the latest Faro arm at that time, and we went ahead and purchased it that day, got that thing in, and then never looked back since. I mean, being able to probe and use the arm as a CMM along with the 3D scanning is definitely helpful because it's a way of checking your work. You can see the points that you've actually probed on top of the 3D scan. So I've never actually had a Faro arm have like a bad scan, a twisted scan or anything like that because the arm uses encoders throughout. So it's constantly tracking your movements. But it is just a great way to double check when you scan a hole, but you also probe the hole. You get to see the circle sketch right next to the edges of the hole. And you're like, yeah, okay, everything's good. Everything lines up. So once we got that piece of equipment, we just started scanning the engine bays, scanning the trunks, creating braces for BMWs. And that I think the BMWs were the first ones we were really making the braces for. And then we got the OTC robot to obviously assist with the welding side of that. So we purchased the welding arm, and then we purchased a positioner from OTC as well and their tailstock. And we also ended up buying a Siegmann block to attach the two. So I don't know if you're familiar with the Siegmann blocks. They're like the welding tables that everybody uses with the 16 millimeter bores throughout it. So they have their universal tooling that
Yeah, I was
fits
looking at
that.
your Instagram earlier and saw that.
Yeah, so we made some adapter plates that John at JSP Fab machined for us. Shout out to John and Stacy. They're awesome people. He's pretty local to us, so he helps us out whenever we need something machined.
Awesome.
And we put together that system and then started programming, learning the programming side of that. I am not the programmer of the robot, so I'll address some of the questions that we have about that. But I have been working side by side with the guy that does program it, our fabricator. And yeah, I've kind of seen the ins and outs and the pros and cons of the robotic welding system. But yeah, so then once we got that going, we started doing some production runs with that, and that's working out well. We're designing fixtures all in CAD, and then having them laser cut, assembling them on the sequence, ordering samples of quantities of 3 on everything that we get samples of for like a new item that we want to proof out. And then we'll burn out three of those items, test fit them on 3 different vehicles to make sure that there's some consistency and that they're fitting correctly. Problem with cars is they vary so much, especially with cars that are 20 years old. Chassis are twisted. Some have been in wrecks. It's hard to find vehicles that are in mint condition. So we try to test fit on as many vehicles as possible so we kind of see the variance between them. And then just recently, last year, my boss had the idea to start getting into wide body kits. So if you go back to before Part Shop Max, my boss actually owned a business doing fiberglass wide body kits for cars. He did that for many years, and then it got hard to compete with China and a bunch of people knocking off your designs, right? It's easy to just get the part and splash it, make a mold, and then just copy someone's designs and hard work. So, and that process is just a very dirty, toxic one, I guess you could say, working in a place with tons of resin and fiberglass dust and things like that. So I think it kind of turned them off. So he ended up starting Part Shop Max, and then here we are today. And he's like, okay, well, I want to leverage all of the newer tech that we have. We have a 3D scanner. We have the capability of getting the vehicle in the computer, designing whatever we want, and making these parts that are perfect. Well, I don't want to say perfect, but you know what I mean. When we talk about fiberglass, you can pull so many fiberglass parts out of like same molds, and you get just variance in them. Fiberglass isn't the easiest thing to work with, and the finished product isn't the nicest. So we figured, well, let's leverage thermoforming and start making the parts out of ABS plastic. Maybe there's something to be desired there with the plastic being maybe more flexible, not cracking. If you're tapping your buddy or scraping the wall with your car going sideways, your corner of your bumpers, maybe this is going to flex a lot better
Not to
rather
mention
than
repairing it. Like, I'd much rather plastic weld over deal with fiberglass any day.
Yeah, for sure. And the other thing too is when we're comparing the fiberglass to plastic, the fitment, like I mentioned, our goal is if we thermoform a part and you go ahead and actually do crack or wreck that part and you want to get a new one, the next one you get from us should fit the exact same way. We're trying to hold a pretty tight tolerance to the plugs or molds that we're designing, and we're trying to really get down a recipe with the thermoforming that is going to be extremely consistent. So that's how we got into that, and we decided to do our first project, which was a wing for an IS300 for a Lexus. I believe it was a hatchback. So my boss went ahead and started the design side of that. I'm not the one designing the wide body kits. I'm so busy throughout the day just sticking to the suspension designs and everything we have going on at the shop, the fixtures, things like that. So he figured he's going to go ahead and design that stuff himself. As far as software goes, I design everything in Solidworks. That's what I've used for the last 10 years. My boss getting into CAD has pretty much, his extensive experience at the time was just using Design X, which is a high-end software that we use for the 3D scanning, but it has a lot of reverse engineering tools, surfacing, things like that. So he decided to start the wide body designs in that, which proved to be quite difficult. And then obviously he doesn't come from a CAD background. So he started getting into using Blender, which is a mesh editor.
Hmm.
And obviously, when we're 3D scanning vehicles, we're starting off with mesh data, right? Triangulated mesh data. So that software seemed to work pretty good for him as far as recreating the stock fender and then stretching it out. Blender has a lot of great tools for that. Then after he found himself doing so much manual work as far as pulling vertices and everything like that to get a nice surface, that he really wanted to get into like great surface continuity and class A surfacing so that when the light washes over it, you get the perfect light wash. And in CAD, we look at that through using zebra stripes. And so he ended up moving on to Alias. He decided to use Autodesk's Alias software. That's pretty much what the high end car manufacturer or just car manufacturers in general are using to get the class A surfacing. So he goes into there and he just killed himself hours and hours. He's spending maybe 15 hours a day for months trying to learn the software and get it down. And he's gotten very proficient in it. I'm really surprised. Like he's just done such a great job. So he's been posting that on Instagram through our Part Shop Max account, but he also started kind of a little sister company called Flow State Automation, which will be the wide body side of the Part Shop Max stuff, the aero parts. And he's doing 3D CAD designs. And then we decided that we're going to go ahead and try our first plug or mold and thermoform our first parts. We didn't own any equipment at the time. So he's like, you know what, let's outsource this to a local shop. Let's go ahead and try this out. So we sent them a mold, and then we sent it to them in CAD. They reworked it and put in their vacuum ports, everything that they do, and then went ahead and machined it, thermoformed parts, and then we got to test the fitment of it. It fit the vehicle really well, and we're like, okay, this is proven to work. Now let's start looking at maybe buying our own equipment. So that began with looking at CR Onsrud and all these routing companies that are really marketing them machining tooling board, which is tooling board is pretty much what all of our molds are made out of. And when I say molds, they really aren't a mold. They're really a plug because
Right.
they are the male version, right? It just most people understand what a mold is. So I like to say mold. But the tooling board that we're using, that's pretty unique to us or new to us. I've never worked with a material that's so dense. You can get it in any density that you want per cubic foot, and that's how it's labeled. So the one we're using right now is about 50 pounds per cubic foot. So some of the molds that you might have seen on Instagram that I've posted in the Haas, they're really heavy. I mean, they start out from like a 200-pound block, and then by the time I'm done with it, it's maybe 75 pounds, something like that. It's very machine friendly. It's easy to cut. There's so many different manufacturers of the tooling board that trying to get the right feeds and speeds is a bit of a chore because the goal is to make chips and not dust. Some
Right.
materials make dust, some tooling makes dust, and obviously the goal is to make chips. So we went ahead and started researching all these things, tooling board, routers, things like that. And my boss was the one mainly doing a lot of the research. I was busy at the time, and he's telling me he's looking at getting a gantry or a routing machine. And I did plant a seed in his head, which was if you're going to be spending so much money on a machine, why don't you get something that we can cut metal with too? So if we need to prototype some parts here and maybe not wait on the crazy lead times we have from our factory in Taiwan, it would be nice, right? But in the meantime, we had people like John at JSP Fab make us prototypes if we want a quick turnaround time to test fitment and stuff like that. But it'd be nice to have that in-house. So once he started looking, he reached out to Haas and looked at their GM2 5AX gantry machine.
Hmm.
And he liked the machine, but he didn't like that it wasn't enclosed. We knew we were going to deal with dust, things like that. And then if we did get into cutting metals, aluminum, things like that, obviously we want to run coolant. Having an open environment isn't the best. So when he spoke with the Haas rep, he said, "Hey, guess what? We got like a new machine coming out. It kind of is the same thing in the sense that it has the massive travels, the articulating head, and everything. Only it's going to be an enclosed system on the or on the VF chassis." So we waited for that. We went ahead and got our order processed. We waited for quite a while. And then finally, they started building the machines. The VR8 was demoed on the Haas demo days. It was really cool. That was the first time we actually got to see it, see what it could do, which is online. It sucks that you can't see it in person or anything like that, or ask somebody what they think about it. with the new
Yeah.
machine. So we talked about the gamble of dealing with a new machine. It could have gremlins, who knows what kind of problems it could have, but we're like, it's okay, we'll work around it. It does what we want it to do. It's enclosed. Let's do it. At the time, the only thing I was really familiar with was like cat 40, just because most machine shops, that's just the norm. And then this thing says it comes with the HSK 63 spindle. I have no idea what HSK is. I start looking it up. I start realizing how expensive everything is for HSK.
Oh yeah.
But we're like, okay, well, whatever, that's what it takes. And when you're cutting tooling board, you do need a high RPM. So for anybody that doesn't know, the VR9 specs are 20K spindle, which I believe is about 25 horsepower. It doesn't have the torque that most vertical mills have. It definitely is a little lower on the torque side. I can't remember if you compare it to like a VF machine, it might be somewhere around like a third of the torque or something like that. I don't even think it's quite at a half. So it's less on torque. So it just means you just got to take it a little easier going around if you're cutting aluminum, take lighter cuts, things like that. So we get that thing ordered. I go down the rabbit hole of months of digging into CNC stuff, right? Learning G code, just learning at what tools we would buy. We're fresh into this, so we don't have anything. We don't have tool holders, we don't have cutters, we don't have anything. The only measuring equipment we had is like dial calipers in the shop, and that's about it. So I went down the rabbit hole, made a full list. We just started ordering everything prior to the machine showing up, filled out a whole toolbox. And at the same time, right when we decided to order the Haas, I actually came across this podcast and I started listening. And I started listening to every single one. And every time you guys talked about something, a tooling manufacturer, what drill bits you like, this, that, I just started making notes in my phone while I'm listening to the podcast. So I had like months and months of notes of all these tools and all these different brands of what face cutter I should use and what end mills and this and that. And so I just started going down the list, started researching all those tools and just started ordering everything that I could that we needed just to begin with. We knew that with what we're doing, we're going to do a lot of specialty stuff, but we should have the basics, drill sets, things like that. So the HSK thing was interesting. We start realizing how expensive it is. So
who'd you end up buying holders from?
So when my boss ordered the machine, he also threw in a Lindex Nikken package. I think it was like a $5,000 package that you can roll into the financing with the machine. So obviously a great brand, right? Like one of the best brands when it comes to tool holders. So we went ahead and started looking at their catalog. And when you do that, when you order through Haas, the tooling package, you have to pay every time you order a Lindex Nikken tool holder, you pay full price MSRP, not the same price that you would just find online, right?
Right.
So pretty much $515 a tool holder, right? Oof. And I'm like, oh wow, we're gonna get about 10 tool holders. That's about it. The machine comes with the 50 plus one tool carriage, right? So we're like, okay, let's start looking at what we need. So I actually at the same time got a call from a Kennametal rep, and he reached out and said, hey, we got our tooling voucher program. And if you get a new machine, send us over your invoice, and then we will give you 25% of the value of the invoice as credit. And when I say credit, that credit means you get to spend up to that much money at 50% off of list price.
Right.
So I was like, okay, well, let me start looking at some tool holders. So we started looking at all their different tool holders and realized that why don't we just go the shrink fit route? The tool holders are the cheapest, right? They're the easiest to manufacture for them, so they're obviously the cheapest. And we wanted really long, stick out long tools to reach deep into our molds. We have really high or tall molds that have deep draws in the thermoformer, so we need to get in there. And so we started looking at the shrink fits, and we really liked the pricing. The pricing was, I think I pay somewhere around like $150 to $200 a tool holder for a shrink fit from Kennametal with the discount. Yeah, so half. So it smokes most prices, right? And then I was really happy with what I was getting because most of the shrink fits that I was getting from Kennametal were either manufactured in Germany or Slovenia. And when I first got my first few tool holders, I ordered some Mitsubishi, like a few staple tools that I knew I'll always be using. So I ordered a 3-inch face cutter from Mitsubishi, their ASX line, I believe.
Yeah.
ASX. And then I ordered their 2-inch and 1-inch indexable shoulder mills, their AXD line.
Hmm.
And so when I got those, I needed holders for those, and I knew those were going to be my staple tools. And for the 3-inch, I I ordered a Heimer face mill holder. And then I talked to my local Heimer rep, and he's like, "Hey, there's a guy locally to you that has a balancer." And he kind of picked my brain about what kind of machine we have and what spindle we're running. So the second he heard that we had an HSK, he's like, "You really want to make sure that those holders and tools are balanced." He's like, it's going to help on anything, even a Cat 40 or whatever. I mean, it's going to help with the longevity of any spindle, right? So I'm like,
Oh yeah.
okay, well, how much can I just pay this guy to like go and balance my tools? And they're like, yeah, sure, they'll be open to it. So I met the Heimer rep there, brought some of my tool holders, and I realized that all of the Kennametal stuff that was made in Germany or in Slovenia was like balancing like great. Like even the Heimer guy was like really impressed by it. And I'm like, okay, cool. So I just got to make sure that this is where they're made, right? So I believe I had one Kennametal tool that was made in the USA, and it was so out of balance. He's like, don't even put this thing in your machine. And I'm like, wow, okay. So I went ahead and told the Kennametal rep. He got me a replacement, went back on the Heimer balancer, put it on. Same out of spec measurement, like so far
Whoa.
off. He's like, dude, do not throw this in your machine. I'm like, okay, so stick with anything that's not made in the USA, I guess. I hate to say it, like that sucks, right?
That's crazy though.
So yeah. So I kind of got a bad taste in my mouth with the USA side of the Kennametal things. I just made sure that I stuck to a specific Kennametal shrink fit line, right? Like a series or family line that was made over there overseas, and those worked out great. And then the Lindex package, I ended up using that to tool up with SK collets and milling chucks and a drill chuck, I believe. Just started looking at ER collets and seeing the run out on those things. I'm like, okay, we got an HSK spindle. Like the tool holders are so expensive. Like everything here is about precision. And I'm like, kind of felt like the right way to go if I'm going to use a collet system to go with something more precise.
Right.
So decided to go the SK route. So we ordered, I think, 4 or 5 different length collet chucks. And then I actually ended up, I'm at the same time, like I'm ordering all these things, but I'm also trying to make sure that I'm keeping the pricing just a little easy on my boss. I'm trying to make sure I'm not going to break the bank or anything. So
Right.
I'm like, okay, do I really need the Lindex SK collets? No, Mari Tool is making some. So I reached out to them, got like their set of SK collets. And then I started picking Mari Tool's brain about making HSK holders. They said within the next year or two, they're working on it. That would have been my first route. Obviously, everyone I follow on Instagram and everything follows or uses Mari Tool. So obviously they have a great reputation, and that's the route I wanted to go from the beginning, but they don't make anything HSK yet. So yeah, pretty much stuck to that. A few Heimer holders, the Kennametals mainly, and then the Lindex stuff. And then as far as the shrink fit, we did not invest in the shrink fit station. Obviously it's quite pricey. And I did not go as barbaric as the torch method, torching everything with a propane torch. So I actually got a good idea from a buddy, and he said you can get these handheld induction coils heaters on Amazon. So we ordered one of those up, and the thing works awesome, man. I mean,
those are for like removing stuck bolts or something,
yes,
right?
yes. So it comes with an array of different size coils. You just screw them on there and fire it up. It takes a lot longer. Like I went and used an actual proper shrink fit station at a buddy's shop to get a tool out, and I was like surprised by how fast it's 3-phase and everything, and heats up the tool holder in it's a couple seconds. I mean, I'd sit there for I think the handheld holder actually cuts out, like has like a safety cutoff at 2 minutes. And the only time I've actually used the 2-minute mark is shrinking a 1-inch tool holder. But that's pretty big for a handheld shrinker, right? So yeah, not bad. I did have to preheat just a tiny bit, just kind of with the torch from a distance. Nothing crazy. Didn't even get into any kind of coloring, but at least like started getting the holder into like the 150 degree mark before I got the induction heater on there. But yeah, that worked out great. So we've been doing that since. And obviously you can see on my Instagram account, like everything we're using is really long reach. And when we first got the Haas and started running it, we did a lot of testing. The first few parts that I cut were out of aluminum, and it was just mainly to make sure everything's flowing, the coolant's working, things like that, and then getting familiar with the cam side. And
well, on your post, I would imagine
Yeah.
Do you use the typical 5 axis, or
No.
it's a special one, isn't it?
Yes, I'll go down that road with you in a minute. Oh man, it's been a long journey, man. It's been a long journey. But we really needed long holders, so the shrink fits worked out since you can get them in 6.3 gauge length, right? That's primarily most of our tools are being held in those types of holders. And the reason is I get a lot of questions like, you have a 5 axis, you can tilt that head, why do you need such long reach? Well, we did a lot of testing in the tooling board as far as speeds and feeds, and I programmed flow tool paths. I try to get the head to dance around and kind of see what kind of finishes we were getting out of that. And the best finishes I get is done in 3 axis.
Mm-hmm.
When the brakes are on the B and C on the articulating head, and those are nice and rigid, then I get my best finish. I did full 5 axis simultaneous, and when the head's dancing around, it just exposes a bit of, I don't know if it's slop or vibration or something in the gears, the mechanism of the
Right.
articulating head, everything like that. So we decided, you know what? Okay, let's just try to machine most of our molds in 3 axis. So we're just going to go with the longest tool holders possible so we get that deep reach. And if you've seen any of my stories, you'll see that, I mean, even with the long reach, I still get really close to the workpiece with the head.
Right.
So
Well, with that head too, I mean, if you're on the front side of the part towards you, it doesn't matter about articulating the head because you're going to run into the casting, right? Like,
there is a safety zone in the whole thing. So it does max out. You won't actually hit any of the machine other than the table. Obviously, you could drive right into the table, right? But you won't hit the column, the casting of the column or anything like that. Obviously, you're clear of the enclosure and everything. But the biggest issue that we had with the Haas is we got it got set up, power brought to it and everything. I had my training days with Haas, which was awesome. They sent me my local HFO sent me some very, very capable 5 axis like experts. I mean, the guys are just so knowledgeable, and I learned
awesome.
so much from them. So my first day was just working the controller. I'm new to any kind of CNC controller. So, and I got to say the Haas is great. I mean, it's very easy to learn. The learning curve is definitely not steep on that one. So the second day I spent programming some sample parts. And then I wanted to see from start to finish what the process looked like and how we'd get there. So right when we went to go ahead and run that first program, the head wanted to do some crazy things.
Oh no.
So when it comes to the post, we used the GM2 5AX post, which is what Autodesk recommended, because at the time they said they're working on a specific VR post for that machine. But in the meantime, it technically is somewhat the same articulating head that's in the gantry machine, so the post should be the same. Well, on the gantry machine, they don't have a tool carousel and a tool change arm that's located right next to the spindle that's stationary, right? So as soon as the program called up the first tool, we went ahead and it brought the first tool over, put it in the spindle, and then the post told it, okay, well, we're going to put pre-position to the angle that we're going to go to, which I think we were testing something at, like, I don't know if it was like a 45 or 90 degree angle. And the first thing that the machine wants to do is articulate the head
Into
and
the arm.
right into the tool change arm.
Oh no.
Yeah. So luckily we caught that. Obviously we're running at like 5% rapid. So we caught that really quick. Then just started talking to Autodesk, and it throughout this whole endeavor, Autodesk has been great. They linked me up with their post guy, Bob Schultz, which is just awesome. He's such a great guy.
That was great.
Gave me his personal cell, and we've just been working out every little detail and gremlin out with the posts, and then he's been applying that. And I'm really the only one that's running the VR9, so I'm pretty sure currently, as of right now, for Autodesk's testing purposes, right? Like, they have nobody else running the VR. So any kind of input that I give Bob, he's able to put into updating the post that'll be the public one, right? And so I don't know how familiar you are with the 5 axis G code things, the G code and stuff like that. But the few things that we've learned along the way with our machine, because of issues like trying to put a tool in the tool change arm, is in the post. The first thing we had to make sure of is that the G53 home position in Z, I can manually set that, right? And I'm sure you can on any other machine. I'm new to it, so I'm not familiar with any other machine other than this VR. So I had to make sure that that was set to a safety height. So I found that like 13 and a half inches and negative 13 and a half inches in Z down. If I was able to, if I tilt the head at 90 degrees, I'll clear the tool change arm. So that's the first thing we changed in the post. It's like, okay, at least if it's going to do a tool change, let's make the Z come down and then articulate the head at a safe height. And then the next thing was I changed the Haas default tool change position to the corner of the machine. So X, these numbers are going to be kind of big for you, I guess. X negative 84 and Y 0. So we have 84 inches of X and 40 inches of Y. And then we have, I think, 42 and a half inches of Z in that machine.
Yeah. So you're like 3.5 Speedios away.
Right. Exactly. So dealing with that big of a work envelope, it is nice. The thing that sucks about it is anytime you have to do anything on the table, you pretty much have to climb into the machine. And then the reason for moving the table out of the way is when we're working with such tall work pieces, the molds that we're making that are they'll be anywhere from maybe 8 inches tall all the way up to maybe 24 inches tall. So just the table moving around with such a long stick out on the tool holder, even in a 42-inch Z work environment, right? It still kind of gets a little hairy. So you don't want to drive the tool across the mold and break it off and ruin the mold, and tooling board's extremely expensive. So we figured, okay, let's change the order of operations with how this thing moves around. The first, once we fix the issue with putting the machine trying to crash the tool into the tool change arm, the next thing was, let's make sure that the order of operations of when it's rotating the head seems correct. So the way the post was originally, it would drive to its location of where it's going to do that tool's operation, and then it would rotate the head, okay, and then it would back off to your Z retract plane, right, in whichever orientation you're at, right?
So you could be into the part then.
You could be into the part, yes, exactly. Ooh. So yeah, it gets very hairy. So the first thing I wanted to do was let's go ahead and change the order of operations so that we do a tool change and then we pre-position at that location and then we drive over to where we're going. It still can get a little hairy because even though your tool is tilted prior to going to its location, you could technically still hit something along the way. But ideally, we're doing this at the highest Z height possible, right? Which for the most part, hopefully would clear any work piece that we have on the table. And then the next stage to that is once the Z starts retracting down to get to its location, you kind of need to make sure that Z retract plane is far enough away from everything. Because let's just say your B axis is tilted at 90 degrees, your tool's at 90, and now you're at the location that you need to be at. Now your Z needs to come down, but it doesn't come straight down to the location. It might come down and jog like at somewhat of an angle. So you could somewhat drag your tool or break it or hit your workpiece. So there's a lot of proofing when we first make our cam program and then go to the machine. We just really have to be alert while double checking everything at 5% rapids or whatever.
Well, and how many are you making at a time? Because I wouldn't think that you're making a ton of molds.
No. So they're pretty much, I've only made one mold right now as of date, the one on my Instagram account. We're working on some other stuff in the computer. We figured we'd start the first project with the easiest item, which would be the wing. And as far as fitment goes, it doesn't rely on any other body panel sections or any other parts of the wide body kit to come together on the vehicle. A wing just goes on the trunk. So we can just test fit that and see whether our scaling and things like that are correct and fit the vehicle, right? So we went ahead and did the wing. We machined that. And conception with this machine is a lot of people probably wonder well, how are you making money with that machine? Well, we aren't right now, and we won't be for a while. I mean, we bought it with the idea of that spindle's not going to be turning all the time. It's going to be hanging out most of the time, dormant. And when we need it, we will machine a mold. And hopefully with time, as we start doing more and more vehicles, the molds will come more frequently and everything like that. But currently right now, there's so much downtime because we're checking every bit of the process, right? We're making a mold. We're checking how good did that mold come out. Then we're going to the thermoforming process and we're testing that. Then we got to get the settings on that correct. Now we got to test the part on a vehicle. And by the time we're ready for the next mold, like it takes a bit. So we made that first mold, and then the next part of this whole thing is using the 5-axis to trim the ABS parts as well. That's the goal. We don't want to sit here and manually have to trim out. There's a lot of excess plastic when you thermoform a part, and we don't want to have to trim that out by hand. So what I'm currently working on right now is designing another plug that looks exactly like the mold, just not as large. It only needs to touch the live area of the part, not all of the excess material. And we're going to be doing some vacuum work holding in the machine so that we can put the part in there, vacuum work hold it, and then just come in and do all of the trimming on the machine normal to the surface, right? Because on the finished part, we want the edge to be perpendicular to the live surface of the part. So that's where and why we actually ended up purchasing the 5-axis machine rather than buying a 3-axis machine, was because we knew that with all these complex curves, we're going to have to be normal to the live edges. So this way we can let the machine dance around and trim the part for us. And one thing that we realized after getting more familiar with the machine is once you start tilting that head, obviously 90 degrees would be worst case scenario with long tooling. I mean, your work envelope just decreases exponentially. It's just crazy, man. If you From the pivoting point of the head to the spindle nose, you have about 8.5 inches, and then you tack on your tool holder and your stick out of your tool, right?
Right.
So
So you're losing like 15, 16 inches aside, something like that.
yes, yeah, that's on a short tool holder for me, right? So
Yeah.
like some of my tool holders, if they're 6.3 gauge length shrink fits, plus maybe I have like 3 inches of tool stick out or something like that, right? We're at 9 inches there, plus the 8.5 inches to the pivot point.
Right.
And if you were to tilt the head at 90, and then I have 40 inches in Y. So if you were to put the head tilted at 90 in the back, and you're losing however many inches there, and then you come in from the front side, you're losing inches there. You're left with a narrow workspace in the center of the table.
Yeah.
So yeah, it's a bit deceiving, and you don't realize those things till you actually get to run the machine yourself, and then you start realizing like, whoa, maybe we should have got a bigger machine. But I mean, we barely fit that machine in our shop. We don't really have much more room for anything bigger. And when you start to look at, it gets crazy to even say this, but the VR11, or now they have the VR14, I believe, those don't grow in Y. They just grow in X.
Right.
Right.
Yeah.
So the 40 inches in Y is the limiting factor. Our X is okay right now. Like we have 84 inches of X, and that's plenty. I mean, we can fit side skirts on a pretty long vehicle, which would be our longest part to have to make a mold for in there. Mm-hmm. And then, yeah, so now we're just hoping that we don't get to that limitation point. And I mean, if we do in Y, then we just can't be normal too. We'll just have to start tilting the tool more vertical. And which brings me to, as far as the cam package that we decided to go with, where we looked at Power Mill and the more high-end software, but at the same time we wanted to get our feet wet. And it is a bit scary to jump into like a big piece of software that's expensive and not knowing how to use it and being overwhelmed with that. So we figured, let's go ahead and try out Fusion 360. And so far, it's worked great. I mean, obviously, we got the manufacturing package because we knew that we'd be using Steep and Shallow, which obviously they put that onto the manufacturing package, which isn't free anymore. So that was right about the time that we were making our purchase for the software. So I didn't lose anything, right? I mean, I know there was a lot of gripes with people using it for a long time for free and then having to pay for it. But yeah, so we jumped into that, and primarily for all of the surfacing on the molds, that's what we're using, and it's working out great for us. We're doing it in 3-axis motion, right? Because I'm getting the best finishes that way. But the Steep and Shallow tool path allows me to do the tool collision avoidance, right? So I can tell it to stay at 3-axis as much as possible until it hits maybe a certain area, and then it'll just apply a tool tilt just in those areas and then go back to 3-axis. So that's kind of nice for us. And in the end, I mean, technically we could sand these molds down, but we were trying to hopefully go straight out of the machine to the thermoformer without having to put a lot of manual work into the surface of the mold. But yeah, so And for people that are curious, as far as the articulating head, we obviously it's different than like a UMC machine. When we're dealing with like the G code of the articulating head, all the Haases use G268 to define like the feature coordinate system. There's two ways of doing it on our machine as far as the post goes, and that's by you can pre-position the head first and then tell it give it your G43 tool length compensation,
Hmm.
and then you activate G268, so it saw the movement that you did to pre-position to a certain point, and then it knows how to rotate along the work coordinate system, right? And then the other way of doing it is by inputting IJK values, right, for the rotations of each axis, which our post does not do. We chose to do it the other way. It's a lot easier. And I know some people wondered, like, why would you get into 5-axis just right off the bat? Well, obviously, 3-axis wasn't going to cut it for us for what we're trying to do with the machine. We need the capability of the 5-axis as far as
Oh
the
yeah, so that was
trimming
one of
goes.
our questions from Molly. No, he said why the decision to jump right into 5-axis seems like a big risk for not having done CNC programming before.
Yeah, right. So since we knew we needed the 5-axis for the trimming process of the ABS plastic parts, and maybe in some of the hard to reach areas of the mold, we figured we'd go that route. And you would think I was really worried that jumping in the 5-axis was jumping into the deep end, and maybe it is, but it wasn't as difficult as I thought it was going to be. I just feel that the software and everything is made it so user friendly that I feel anybody could just jump into it and get into it. I mean, Fusion 360. The only difference when I'm doing something in 5-axis is that when I pick a tool and I pick a tool strategy, I pick a tool orientation and specify the tool orientation, right? So my Z plane to some weird angle or face that I'm going to drill a hole through, or face at an angle or something like that. It's just so simple. I mean, that's it. And then as far as the 5-axis tool strategies in Fusion 360, I know there's not too many of them right now, but the ones we have used are like swarf cut. So that's worked out really easy for me. I mean, the area we use swarf is 5-axis swarf is to trim the ABS live edge part that's normal to the surface. So as far as the toolpath goes, you're picking the bottom boundary and the top boundary of a plane, or sorry, not a plane, but a surface that I already have in
Right.
CAD. And then it just applies the tool to be right against that surface, and then it just follows it and tracks it all throughout. I mean, I understand that if you're looking at the G code and everything, yeah, if you were going to handwrite code, I'd say it's definitely more difficult. There's a lot more work to it for sure. But in this day and age where pretty much anybody can buy this kind of software and get into it, I mean, it just makes it so much easier. The first few weeks getting into Fusion 360 and messing around with things in 5-axis just made me so much more confident in it. I'm like, oh, this isn't as bad as I thought it was going to be.
Yeah.
You know?
Well, I'm sure it helps too that you guys bought this machine for a purpose, so you're not in a rush to make a million customer parts. You're able to take the time to really understand what you're doing.
Yeah. And as far as the Haas experience goes, I loved it. I mean, obviously we've never ordered any or purchased any kind of other CNC equipment, so I don't know what it's like to deal with other manufacturers, but Haas has been great. The support has been awesome. I think I've been a bit of a special case because new machine, they wanted to know any little details, errors, things they could fix, everything. So they were on me like glue. I mean, I had like a Haas guy coming like every other day to the shop just to come check and see what we were doing with it. And then anytime I had a little error, whether it was post related or the machine, I pretty much had Bob from Autodesk in the email chain with Haas, and we just all worked out like every problem and most of the gremlins out all together. And they've been on it. It's been awesome. But there have been some pitfalls with the new machine, and some of it is, well, okay, so we got auto doors with the machine when we got it. VR9 is so big that the doors are extremely heavy, so like they start to get a little clunky, just rattly, and kind of we were getting some like grinding noises coming out of the doors because they're so heavy. They start to sag over time a bit. But once they've settled into place, they had to come and realign the doors and make sure the motors are where they need to be in the tracks and everything like that. Now everything's been good. Then the next thing is when we purchased the Haas, the website page for the VR8, VR9 actually had a lot of like the copy and content from the gantry machine on there because it hadn't been fully updated yet. So there were obviously some differences between the machines, and our machine didn't come with a second home position. Right. And I didn't know if like, oh, once we got it, I was like, oh, it'd be nice to have a second home position. Maybe it was supposed to come with the machine, or maybe that was like something we were supposed to pay for.
Right.
And then I go back and I check the website, and it says like one of the standard options that comes with it is second home position. Well, I'm climbing into this thing to do a tool change every single time, right? Or to load a tool, right? New machine, and got to load all these brand new tools in. So I have to climb in there. And what was becoming a pain was, so on that spindle, you putting the HSK in there, it's obviously the spindle is so deep from the door, and the door is so tall that I almost have to put a knee up onto the edge of the door and get up there, or a knee onto the table and get up there just to get in there, right? So then, well, if I can articulate the head, why don't we make it a little bit easier and then just rotate C 90 degrees, rotate B 90 degrees towards the operator, so I can just see right inside of the spindle and then just load a tool right into it, right?
Yeah.
So you got to bring Z down, you got to rotate C, you got to rotate B, you got to do all these things manually and jog it there, and then you put a tool in, and then you got to go back that way too, because you're probably so close to the table. If you hit like home return, you'd probably just like tilt the head and crash the tool right into the table, right?
Right.
So I got to manually do all this, and I did so much of it, and I'm like, you guys need to have a second home position, right? And they're like, oh yeah, we actually made it a standard option. Let me get you one of those. So they come and install one on the machine. I use it for the first time and hit the button, and then it just almost crashes itself immediately. So I'm like, okay, same issue we were having before is the order of operations of when it's rotating the head versus when the Z is moving, right? So I'm like, okay, hey, I was like, I love the second home position, but you guys have to change the order of operations on this. And they're like, oh, sorry, we can't do that. That's like fixed in the software, and something you can do about that. So now I got a second home position. It does nothing for me. So I just programmed it to just bring the table to me, and that's about it. Yeah.
That's frustrating.
So hopefully once the tool carousel's filled up, we're not doing job shop work. So I'm not constantly having to pull tools in and out. For the most part, they live in the machine. So it's only a burden when I'm loading the thing up, or gotta make like a insert swap or something like that.
Well, and if it makes you feel any better, there's a similar issue on the Brother M series. Like they have in the control the option for a tool change position, and that's for the R series. Like both the R series, which is the pallet changer, and the M series, which is the 5-axis, are moving head machines instead of moving table. So it'd be super nice to have the head come all the way up to the door so you could just load tools and go. Well, they seem to refuse to enable the tool change position on the M series. So like the options there, you can see it and you're like, come on, just let me set a home position for tool change. So it's not just Haas. It's all throughout the industry. There's little quirks like that for sure.
Yeah. So the next thing, now that I've gotten more familiar with the G code and everything, is I just got to make a program to just bring the spindle to the position that I need it to be at in the order that I need it to go to. So that's next. And then the next issue that I had was when I cut my first aluminum parts, I felt like I kind of was a bit aggressive on the cutting sides, on the speeds and feeds, just because I used primarily my Mitsubishi tools, and I went on their data sheets and just went off of the recommended speeds and feeds and kind of did that. But at the same time, you have to take into consideration, which I know a lot of people are curious about this, is the rigidity of the articulating head. And it's not as rigid. It definitely is not as rigid. So there's a bit of deflection. So I ran these tools at a pretty fast speed, and it sounded fine. I mean, it cut great and everything like that. It was okay. The finishes were decent, not the best, but it did a great job. But then once I started putting calipers on the part, I started noticing that things were out of tolerance, and you got deflection. And I'm new to this, so then I started learning too that on the cam side, we could do a repeat finish pass just to get rid of any excess material that might have been there due to deflection or anything like that. So that definitely helped. And then the next thing, I was like, okay, well, why don't I just design a block that's like a dimensional test part that'll have pockets, it'll have some bores, it'll have some contours, some outside contours to be cut with two different tools. And let me just like double check all these after manually measuring them out and see how close this machine is. And the tooling board is pretty forgiving. It is cutting. I don't want to say it's like cutting butter, because it does have some rigidity to it. If you come into the material too fast, it'll definitely it'll definitely be rough. But I do cut most of the tooling board at like 450 inches per minute, which is pretty fast.
Oh
So
yeah.
our machine is not obviously not like a, they don't make it in like a super speed or anything like that. So our rapids are 600 inches a minute, and then our cutting feed rate's 500 inches a minute. So I'm right on the higher end of that. So that's what I found to work. I mean, chip load on this stuff is around 15 thou. That's where I'm getting some decent chips. We make a little bit of dust, but not too much. It mostly, when I'm doing heavy cuts, it obviously works great. But when I'm 3D surfacing, things like that, I'm still making chips, but I am still making a little bit of dust. So we've just been working on fine tuning that. You're never going to get rid of that. The dust, it's always going to be there. And with the articulating head, it's not like this thing has a vacuum system that goes right up to the spindle like you see on routers and things like that, right? So I just got to kind of deal with it. And so I went ahead and designed this dimensional test part and ran it at the 450 inches per minute, two different tools, pulled it off the machine, checked the dimensional accuracy of it. And it was, most of the features were around 4 thou. I believe it was 4 thou too big. And then the bores were the worst. The bores, I was around like, I think 9 thousandths of an inch.
Too small.
Undersized, actually, too small.
Yeah.
Yes. So I was like, whoa, coming from just doing precision work and things like that. I'm like, I can't have things that are 9 thousandths of an inch off. Why is this happening? So I went ahead and started playing around with the cam stuff and got a few pointers and tips for some people on Instagram. And then I started applying the repeat finish pass and everything like that. And then the one thing that really helped was, I was like, okay, you know what? On the finish pass of every single feature, why don't I just run the thing at 50 inches per minute and just see if it has something to do with the speed, right? And sure enough, I cut the features at 50 inches per minute, and then all the tolerances were cut in half. But
wow.
at 9 thousandths, a bore being 9 thousandths undersized, even cutting it in half, being around 4.5 thou undersized is still like quite a bit. And we're dealing with machines that work in tenths, right? So there's some things that I still need to test and apply, which in my post from Autodesk, I actually have a checkbox where I could make it so that the C axis, or the knuckle part of the articulating head, points in the direction of the way the cutter's going. So that way the B axis can't deflect. It's not on its rotational direction, right?
I gotcha.
So I haven't tried that one yet. That's the next thing I'll probably try. And that makes sense for things like that are more prismatic. You're going around like a rectangular perimeter or something like that. I don't know if you go around a circular profile, whether it like keeps rotating the C and keeps it in front of the direction that it's going.
Oh,
so
that'd
that's
be
still
interesting.
something to test. Yeah. And then the last thing, which is why the machine's been down for the last couple of weeks, is when we first got the Haas, I got all these brand new expensive tool holders, and after loading tools in and out of the machine, I started to notice that on the taper of the HSK, I had a little wear mark. It's something that was visual, but you couldn't feel it at all. If you rub your nail on it, couldn't feel it at all, but it's still visual. And I brought it up to Haas. They were like, that's nothing. Don't think anything of it. And then we ran our first mold. We've been putting a little bit of time on the machine. And then I start realizing that wear mark isn't a wear mark anymore. So now my tool holders are getting like a scratch in them, right on the taper. And I'm worried because, from everything I've learned is like the spindle taper is just like, it's a holy area of the machine, right? You just don't, you need that thing to be perfect. No, you don't want chips in there. You don't want any kind of dings, scratches, things like that.
Oh yeah.
So we went ahead and had a tech come out and look at it, and we found a ding on the spindle taper. And Haas doesn't make these spindles. They're made by a company in Italy. So they started figuring out how they were going to fix the issue and stuff. And I just spoke with them yesterday, and I think they're going to be replacing the entire spindle, which I'm sure is extremely expensive. If I had to guess, somewhere between 30 and 50K for that spindle. So they don't even know what that entails, though. They've never done one of these. Right. Yeah. So everything's so new on this machine. And the other thing is, HSK is really new to like at least my HFO. I mean, I'm like, how many HSK machines do you guys have out in the field? And they're like, oh, it's pretty new to us. So like, there's only a few UMCs that we've seen that have HSK, and that's about it.
Right.
And a lot of the guys, when they come to the shop, the techs to like work on our machine, they're like looking at the tool holders and they're like, "Oh, this is different." And I'm like, it worries me a bit. Like, oh man.
Well, I can't remember if they came out with that in 2016 or 2018, but it's a fairly recent spindle option, even
right.
in
I think
general.
it might have been 2018.
Yeah.
Yeah. And so obviously there's a lot of 5-axis guys on Instagram that I talk to, and they've all been really helpful, guys that run high-end machines with HSKs and everything. And I asked them, I'm like, hey, should you have a ding like this in your tool holder? What should the wear marks on the tool holder be like? Things like that. So when they came out, they went ahead and put a drawbar test on our spindle, and obviously we don't have pull studs on the HSK. If you're familiar with it, they got the fingers that spread out, right,
Hmm.
and grip the inside of the tool holder. So they went ahead and put a special tool on there and tested it and found out that it was below the gripping force range,
Oh,
just a little bit, not too bad, but still out of range. And I'm like, oh, okay, so we have this ding in the spindle. The drawbar is not adjusted to the correct length for the proper pull force. So there's a lot of things they need to work on. And then just prior to actually finding out that they need to replace the spindle, I was doing something on the machine, and I commanded a tool change and like just turned around for a second, looked away, and once the once the tool change arm was putting the tool back into the spindle pocket, obviously on the Haas, the spindle pocket flips down, right? And it puts the
right.
tool right in. And then right when it flicked back up to go into the carousel, it just launched my tool and just hit the enclosure of the machine. Fell. Obviously, I have a massive machine, so it fell like 6 feet to the ground and hit like the bottom tray. Luckily, I didn't like chip a tool or ding anything. Luckily, it didn't land on the table
Right.
or anything like that. But I had the tech come out and look at the tool pockets, and I had a tool pocket go bad.
Oh my
And
goodness.
and then I'm like pairing this up with like, okay, HSK is new to Haas. Like I'm like, okay, like I don't want to have these problems. I was like, all this stuff is so expensive. I don't want to be throwing tool holders as pockets randomly go bad when things
Oof.
like that. So it's been a little worrying and stuff like that. But for the most part, they've fixed every single issue and they've been on it. Like pretty much all of my fixes have been like next day, other
Yeah.
than this spindle issue that I'm having. So in the meantime, I'm gonna try to run the machine just a little bit, just not enough to like really hurt my tool holders. I told Haas, like, look, I know you guys are not going to buy me a new Heimer tool holders, new Kennametal tool holders, new Lindex tool holders. So you need to fix this problem. And yeah, I guess replacing the spindle seems to be like the way they're going to go about it, which is crazy to me. You would think you're just going to replace the tapered section of the spindle, but yeah, it is what it is. So
That's good on them. I mean, it's a rough situation for everybody involved, but I'm glad to hear that they're treating you right.
yeah, yeah, for sure. And then the only thing left, the post with Bob has been figured out with Autodesk for the most part. Everything's working. I can make parts. The machine's moving in the nature that I want it to move in. Everything's working great on that end. The only issue that we've had since day one, and they've come to the conclusion that it's a Haas issue on the controller. It's a software issue. They have not created an update for it yet, and that is that when I program parts in 5-axis simultaneous, I pick whatever speeds and feeds in CAM, right? And when I post that out, the controller is having an issue with the speeds and feeds and errors out and gives me either a B axis or C axis max feed rate alarm.
Oh,
Um,
interesting.
and it kept doing it. So me and Bob worked on troubleshooting that and finding out like what would work for me to get me by in the meantime. And that's pretty much lowering the degrees per second movement of the B and C axis to the like bare minimum. So if I program something in CAM at 200 or 300 inches per minute in 5-axis simultaneous, my post right now is acting like a governor and it's limiting it down and changing those values to a fraction of that speed, and then it's like running at a snail speed. So luckily, I haven't been using the 5-axis simultaneous because I couldn't really even do any kind of speeds and feeds testing, because it doesn't matter what I put in on the cam side, it spits out this like extremely slow speed on the machine every
Right.
single time.
Yeah.
So I'm just waiting for them to figure out that issue, and then hopefully it's smooth sailing from there.
I'm sure it will be. Well, let's
Yeah.
jump into some questions. A first one that we got two of from Beige Power and also from Molly No is they wanted to know more about the OTC welding robot. How easy is it to set up? How long does it take to program? Anything you learned that was unexpected? And you said already that you don't program it directly, but you work with the guy. So what can you share with us about the OTC robot?
Yeah, so anybody that's ever seen any kind of robotic arms being controlled, they're usually done by pendant. And that's exactly how our machine works. We have a pendant and we have a computer monitor that's just reading off of the computer that comes with the robot, and we're seeing on the screen exactly what you see on the pendant screen. Really, is all you're doing. It's just for a bigger display. But on the pendant, it's pretty overwhelming. You have a lot of buttons, a lot of controls, and there's no descriptions on them. You have to read the manual. They're all just characters on there and stuff. And there's multiple pages. There's like a shift button for like every button is a different, uh, you know what I mean? It's like a different command or whatever.
Right.
So once you learn the pendant and get through the pendant, then the programming process is the way we do it right now currently is just point to point. So so we go ahead and tell it if we're doing a straight weld, we're going to tell it this is going to be your starting point, this is going to be your end point, and then it's going to automatically program a straight line from there to there. But then we also can keep branching off of that path and add an arc to the end of it, or we can program an entire arc. And I think welding robots are great, and the way they're great in certain situations where the way you see them marketed, where they're doing very simple industrial parts like a tube being welded right to a plate just 90 degrees, like that's very simple. You could program that and it's going to go around that thing and burn it out. It's going to look beautiful. It's going to be extremely consistent. It's awesome. The issues with the robot is the welding process is extremely sensitive to the tolerance of the parts. So when we program a point to point and tell it to weld, it doesn't veer from that path, right? So it's very important for our fixtures to be on point and repeatable, but mainly it's the components going into the fixtures. So the weldments that I described to you earlier that we're doing on our robot is 3 tube laser parts, right? Some of them are straight, some of them have bends in them, and then plates that have a bunch of press brake work on them, right? So if you have obviously 2 flanges that are bent on a piece of sheet metal, we're welding the gap where the flanges meet, and there's variance there. So when your parts vary a little bit and that gap varies, whether it's one end has a bigger gap and one side has a tighter gap, or between parts every time, like they're varying in different ways, when you're welding, the robot's not veering off that path. So the weld attracts naturally, if there's a gap, to the closest piece of metal that it can get to. So you might see your weld path like walk, like it might all of a sudden start to weld on one side of the sheet metal, or whether it's two tubes meeting each other. It might decide to just start like grabbing one side and the weld is fully on one part and maybe crosses back over and welds where it needs to, or gets onto the mating part. But it's so hard to keep the weld where it's contacting both parts and making like the correct weld that you need, right?
Right.
So part of the issue with that is when you outsource sheet metal work, tube cutting, tube bending, things like that, I mean, you're not controlling the QC and the processes of that in-house. So you don't have control over the tolerances. The shop that we use, Cal West Manufacturing, they do an awesome job. They have some great equipment. But at the same time, over the years, they have upgraded their equipment. So if I designed a part 2 years ago and they were doing it on a certain press brake and they were bending it, they were doing the laser tube cutting on a certain machine, and then the tube bending on a certain machine, and then upgraded those machines, now it affects me. Now my program is out of whack. The parts come out even better to like my CAD model, and now the gaps are different or not where they were before. There are no gaps now, and now we have to go back and nudge every single one of those points that we programmed with the robot. So there is it gets a little difficult there. When we get a pallet of 30 or 50 parts to do a production run, we weld the first part, and then we see where we need to make some changes. We'll make a few changes by nudging those points, and then we'll load the next part, and then we'll see. And then we kind of find the average of all these parts. So maybe by the fifth part into an entire pallet worth of a production run, we might like have narrowed it down and got a pretty good program working, and then it runs. And then, but like I said, the next time you reorder that pallet and you get it in, you might be doing the same process all over again.
Right.
And I know that one of the questions on there was is there any kind of software or a CAM that we're using for that? We looked into remote software or offsite software for programming the robot. It is definitely a specialized software. One of the ones that we looked at, which is the higher end software, is called Octopus. And I mean, I think that runs like 20 grand. So it's definitely not cheap. So we were wondering if it made sense for us to go to the offsite programming so we could do it in the computer, because we have our fixtures in CAD. We have the design in CAD. We can import it. Now, the the hard part about manually programming on a part is you can't see where your previous points that you've programmed are, right? You have to drive the robot to that point with a teach tip that we call it, just like a pointy tip that's spring loaded so you don't break it. We swap that out with the nozzle, the welding nozzle, and we'll drive that to like the point, and then okay, you can see like you can lock the tooltip and you can articulate the gun any which way you need for clearance or for push angle for the welding process or anything like that. But then once you move on to your next point, you don't see where you were before, right? So you don't see what the movement looks like in between.
Right.
So without dry running in it, and it gets so time consuming. So we were like, okay, maybe if we use software, we could do it all in software and we can actually see the path. We could see a trace of the path that the robot's taking and everything like that. And we can see the angle of the gun. And again, in theory, the way they market these softwares, they work great when they show you a sample part that they do, but the real world use cases of these types of things is so much different. I don't think that we have like any 90-degree junctions of like whether it be tube to tube or tube to plate. Everything we have is at some weird angle, a compound angle of some sort of a tube being notched and going into another tube or up to a plate. And when you get into the CAD side of getting tubes laser cut with notches on them, the laser cutter always cuts normal to the tube surface, right? So as you're going around a tube notch, you're going to have one side of the cut. When you mate this part to another tube, you're going to have one side of the laser cut leave you a valley for a weld, right? And then the other side is going to be like the opposing side or the opposite side is going to be the tube meeting the other tube without a valley, without like a chamfered edge, you could say, right?
Right.
Normally, on the old school method of doing this by hand is after you notch a tube, you go on the belt sander or grinder and you put that chamfer around the tube for your weld. So the way these items like meet in CAD, it makes it difficult for their software to actually trace. The second you have like a gap, let's say, which we design everything with a gap because we need it all to fit. I don't, if I have two tubes on the left and right and I have a cross tube connecting the two, I don't make it a perfect fit in CAD. I have a tolerance gap section. Well, right. The softwares don't like that. They're like, oh, well, we can't weld here because there's a gap. So we tried trials and stuff. We tried extending our tubes and making them just like the version we would use for the offsite software. They're actually mating. The tubes are actually touching, and we try to drive the path around it. But in the end, it just made no sense. We just figured there's no point in spending the $20,000 if the software is not doing what we need it to do, and it's going to take almost just as long programming it in there than it is manually out on the machine. So
yeah, that's crazy.
So for the most part, we're doing everything on the machine itself, and it's all a very manual process.
So what can you do to mitigate that issue with the weld walking? Have you guys gone to like bigger wire sizes and things like that to try to?
Yeah. So when we first bought the machine, we did it with the idea that like we wanted our MIG welds on the robot to look like our TIG welds. All of our products are welded out, and the ones made in Taiwan are all hand TIG welded.
Oh, wow.
Yeah. So we wanted a MIG like TIG look, right? So we wanted to get the dime stack look and everything. We definitely didn't want it to look like a squirt gun, right?
Yeah, no bird droppings.
Exactly. So we've been just trying to fine tune that process, and so we played around with wire sizes between like 030 wire, 035 wire, and then the way you program the weld in between point A to point B is it's not the same way you do on, at least on the OTC, it's not the same way you do your manual welder. On your manual welder, you have wire feed speed, and then you have your amperage, right? Well, we don't do that on the OTC. We're pulse welding, first of all. It's not like trigger welding on a MIG welder. The pulse weld is completely different. It actually is much stronger. People have this like bad taste in their mouth that we do trigger welds with the robot, but we've had samples that have been pulse welded on the OTC and then checked for like strength testing to see if the weld would crack and stuff like that, and actually held up to a lot of like different styles of welding that you would think are far superior. So there's definitely no issues with the pulsing. So we decided to go that route because it gives us the look that we need, the stacked dime look. Now, when you have those gaps, that vary and the weld pulling from left to right or whatever, you end up with those stacks not looking as consistent, right? So when, like, going back to the programming of point A to point B, instead of using the wire feed and the amperage, we're using on time, which is how long that pulse spot is on for. And then we're also using, I guess you can say it's like a step over. How it's they call it pitch. So it's distance between each puddle, pretty
Hmm.
much. So the hard part is you might program, let's say you program a 3-inch long section, right? And you tell it you want a pitch of an 1/8 inch, right? So it's going to put a puddle every 1/8 inch. But the second you start, you don't know what the end to end distance is. When you pick point A to point B, we're driving the gun there manually, right? We don't know what the distance is or the length of the path. So when you pick like an 1/8 inch, let's say 1/8 inch works great for the dime stack look, on one weld, it might look great. And then on another one, it might not, right? You're going around an arc, it's a little different. And then your start and end points will look different. Normally, the start will always look good, but you don't know where you're ending on that last point, whether you're like in between the pitch. So if you're in between, it's going to stop at the last puddle right before, and then your weld comes up short. Then you overprogram your point, so you go past that, and then it starts to turn into like a real mess of like where you've programmed things. So you gotta kind of remember that when it comes back to getting a new production run and going in and moving all those points a little and nudging them. You have to remember, like, okay, was there a reason why this point was allowed out a little bit farther than where it should be? It might have been because we were compensating for the weld to end at a specific point.
Right, right. That
And you
makes
can't
sense.
see any of this, right? It's all just in the code and stuff, and you have to manually drive it there and run parts to actually see it.
So, not to put words in your fabricator's mouth, but how does he feel about this whole thing? Because I know a lot of people are nervous about robots taking over their jobs, or does he feel like this is helpful or a hindrance? Like, what has he shared with you, I guess?
So we all went into purchasing that equipment with like it being, we kind of did it as like a group decision, but hoping that it's definitely something that's going to benefit the company. It's going to make the process a lot faster than manually welding these by. For him, I think in the beginning he wasn't worried about it because it's like, well, there needs to be somebody to program it and run it, right? And it's going to be him. So more, if anything, more job security, right?
Good.
Someone's got to run it. So then we've talked about that a lot though, and we've gotten the comments on Instagram and stuff like that about the robotic welding. Oh, it's taking people's jobs and this and that. And here's the thing. Sure, you can take any Joe Schmo off the street and teach them anything, right? You can teach them how to run a robot, but you still need a lot of welding experience to know how to program that robot, even though you're changing from a different way of adjusting amperage and wire feed, but now you're dealing with on time and distance and things like that. It still takes a good welder to know, hey, did I get enough penetration in that part? What do I need to do to, get this weld flatter or to penetrate a little more? Maybe it's not amperage. We can't turn up the heat, but we could turn up on time. It's spending more time in that puddle, things like that. And it definitely does take an experienced person to do that. So for anybody listening that has that mindset of robots taking over their jobs or anything like that, I mean, I just feel like we got to get with the times. I mean, a long time ago, manual machinists had to learn how to go and get into CNC, right? I mean,
Right.
and that's just the exact same. It's the exact same thing that's happening. So
Well,
if anything,
I think it's important going back to what you said at the beginning. Like, you guys have a factory in Taiwan, and this allowed you to bring that manufacturing in house, or like some of it at
yes.
least. So you're creating jobs that wouldn't have been there otherwise without this kind of automation.
Yes, very true. Very true. But yeah, when you look at it from the bigger picture, sure, maybe you need less fabricators. And if you're doing a lot of production work or something, maybe you could do it with less fabricators and just welders, less manual welders and more guys that are learning how to run the robotic welders. Maybe one guy could run two machines rather than the old school way of doing things is one person welding one part. So,
Right. And maybe you can pay him more because of it. Like,
yeah,
it's probably a
exactly.
better job than one guy sitting there manually doing it.
Yeah, for sure.
Awesome. Well, jumping on to another quick question. Seven Sir HC asked, when are you going to make an SW20 wide angle kit?
We definitely don't have that in the works. I don't think we'll be doing anything for that Since I came and started working at Part Shop Max, I helped with some of the first projects I worked on. I helped with optimizing the C6 and C7 Corvette suspension. And the
Yeah, I
way
saw
we,
that with Matt Field, like that you were able to make those
yeah,
parts for him. That was really cool.
yeah. So I got to work with Matt and become friends with Matt, which is really cool. We sponsor a few Formula Drift competitors, Matt Field being one of them, Chris Forsberg being another one. So we've worked with, well, my boss has worked with Matt since day one, and we've always done everything we possibly could to help him. Always making him custom stuff, just and making him custom parts for whatever vehicle he's been competing with. But at the same time, we use what we learn from that to apply it to our kits that go out to the consumers. And so when I first came on, it started with the C6 and C7. They're very similar, so it's easy to work on those two projects at the same time. And then the BMW E36 and E46 suspension was already developed prior to me being there, but it had a few little pitfalls that we kind of fixed on it. And then the E36, we're actually currently going back on that right now and optimizing it to be much better. So many of these vehicles, like once they change over from one generation to another, have so many similarities that you get to reuse a lot of parts. And there's a misconception a lot of the times, like, oh, well, you know what? It worked for the older chassis, so as long as it bolts onto the new chassis, it's good enough, or something like that. So with the BMW, it was the opposite. We designed the E46 suspension and then saw that it would fit the E36, but we ended up finding that it's putting a lot of leverage on the frame. So we're like, you know what, let's go back and optimize it and just make it work a lot better for the E36 customers. So we're currently working on that. The last project I finished before that was IS300 Lexus. And we did a full front and rear suspension system for that one. And then the next one, so we purchased every vehicle that we did. For the most part, we purchased almost every vehicle that we designed suspension for. And we
Oh, that's
build it into a
awesome.
shop car. So we have a lot of shop cars. And then the ones we have in trailers right now that are sitting collecting dust that are waiting to be worked on, a full suspension design for, is we have a Miata MX-5 and we have a newer Mustang, the S550 chassis.
Okay.
So those are coming up next, I believe. I don't know which one first, Miata or Mustang, but we might throw in optimizing some more things on Scion FRS chassis that we already have products for, but we wanted to go back and make things a little bit better since we've learned some things over the last couple of years.
Nice. That'd be
Yeah.
awesome. Triple Caution Machine Works asked, what's the most bizarre thing you've been asked to scan?
Well, I got some funny friends, so sometimes I'm getting texts when they see my Instagram stories of me using the scanner. Sometimes I'll get some text saying "send scan" with some sort of sexual innuendo to it. So yeah, that's funny. But for the most part, like, really, I haven't actually done any weird things. I mean, as far as CAD design, I've designed all sorts of weird trinkets and weird ideas and inventions that people have worked on and things like that as side work and freelance work. But the scanning has really been in the norm. I mean, for the most part, obviously, the last couple of years I've been scanning lots of cars and suspension, but really everything's just been manufacturing related for the most part. Always just parts, really.
Okay.
So yeah.
And then JSP Fab, John asked, what's the biggest unexpected surprise going from design work into machining?
I wasn't really caught off guard too much because of like having previous experience with manual machining on Bridgeports and things like that. The G code was obviously something like new to learn for me, but I finally realized like why I always heard it's easier to program like items that are defeatured in the sense of chamfers and things like that. As a designer, I like to make my parts look great and look awesome, but the one thing I have had going for me is knowing the machining process. I've always definitely designed my parts with the intention of them being machined, or knowing how the machines work, knowing how cutters work. I'm not making sharp corners in pockets and things like that.
Right. But you're also not hitting the fill it all button.
Yeah, right. I try to stay away from fillets. Me personally, well, what's funny is me personally, I like the more chamfered look to things, so I try to apply chamfers for the most part. And obviously those are easily defeatured. But yeah, I've always made blueprints and sent things to machine shops with the chamfers in there. And now once I started programming, I'm like, if I ever send something to John or anybody else from now on, I'm going to go ahead and suppress those chamfer or fillet features and give it to them and say, here, man, just put the chamfer here. And this is the size it needs to be. Call that out in the print and just make life so much easier. because now I get it. I understand. It definitely is much faster and easier. And then the other thing is that's caught me off guard might have been like how long it takes me to program a part. I wouldn't say I'm like extremely slow, but I'm obviously new to it. But I am pretty meticulous. So when it comes to like picking tool paths and applying them to a part, like I'm it takes me a lot of time because like I might be playing around with a couple different tool paths to see which one's the best one, which one's more optimized, and which one looks better, or which one's going to leave a better finish or something. And I kind of overanalyze those things. So by the time I could design a part and then have throw it in a cam, and then I could burn so many hours programming and looking back and thinking like, man, it wasn't even that difficult of a part, but it's taken time. So obviously that'll get faster with time, but surprisingly, like I mentioned earlier, the 5-axis programming has been a lot easier than I expected.
Good. Yeah, that's great to hear. And then the last question we had from AM Metals was, what future chassis are you going to support with the vacuum forming stuff? Carbon Kevlar vacuum formed E36 full over fender kits, please.
so so as far as I don't know if many people know like what the wide body kits how they actually mount to the car, but what we're doing is definitely over fenders, and the side skirts are everything's over, right? So you're not replacing any of the OEM components. So you're either going to use like a 3M double stick tape to adhere to these parts, which is actually very strong and rigid, or a lot of people like the look of riveting over fenders on there and showing the hardware, the rivet heads, so things like that for some sort of styling and stuff. So the bumpers that we're creating that mate into the wide body fenders that we're making, and the rear quarter panels and the side skirts and any kind of bumper end caps, all that stuff is made to just go on top of the OEM car. Obviously, if you're going wide body, you're looking for wheel clearance. So underneath the over fender, you're obviously going to trim out your OEM panel. And for the most part, I mean, you can trim it as far back as you want. You can get rid of most of that weight, most of that metal in there. And then what you're really using is we're just keeping the OEM fenders and body panels for their mounting flanges and mounting purposes. That stuff is very hard when you get into into molding, even if it's fiberglass or anything, like having to do all those return flanges and all the mounting holes and everything like that. That becomes a real pain. So we wanted to like get into this field with something much easier for a customer to put on their car and much easier for us as far as the processing goes. We're not designing all of the tabbing and everything like that. So as far as his question goes, we've completed the design for the 240SX S14 chassis. My boss finished that one out, and then that mold that I made on the machine was the trunk wing for that. And then now that we're like proving out and coming to the final stages of proving that wing fits, we're going to go ahead and start making the molds and manufacturing all the rest of the body components for that car. And then he had previously started working on the Lexus IS 300 body kit. And he now learned, after months of learning and getting better at the Class A surfacing and everything, he's going back and refinishing that one and getting it to like the standard that he's at now. And so I think that'll be next. And then after that, I know we played around a little bit with some C6 Corvette fenders and stuff like that, and BMW E36 and E46 ones. So I think we might tackle the full vehicle body kit of those. But his question is, we're not dealing with carbon Kevlar. It's a completely different process. So I think he's talking about like vacuum, like resin bagging, right? Mm-hmm. Which is completely different. So since we're just thermoforming everything out of ABS, we're just kind of stuck to using plastics, primarily ABS. I don't know if maybe we'll test or experiment with a different type of material, maybe something that's more flexible, better for the guys that are constantly dashing into each other and letting the panels flex even more and then just spring back into shape. But for right now, it's all ABS. And yeah, I mean, that's pretty much what we have in the pipeline. And yeah, I don't know, we haven't really thought about any chassis that we'll be doing after that yet. I think we just got to prove that all of these that in the lineup will work, and the fitting and everything's working the way we want it to work, the processes. Yeah.
That's awesome. Yeah, it's I was looking through FlowState's Instagram, and it's really cool seeing not only the process of vacuum forming, but just all of the design that goes into it behind the scenes. And it's a really neat process. And like you said earlier, ABS makes sense for the market you're going after. But these aren't show cars. These are cars that are getting down and dirty and Robbins racing kind of things. So
For sure, for sure. So we wanted to be able to make a product that like could be show car worthy. So the plastics that we're using, like the ABS that we're using, is not like your typical like cheap hair cell ABS plastic sheet. Like the wings that we were thermoforming in the videos, each one of those plastic sheets costs like $75, the raw material of that sheet of plastic. And we use, once you trim the part out, I mean, we're probably only actually using maybe 25% of that plastic on
Right.
the actual finished part. And the rest is trash. You can't reuse it. We could recycle it, obviously, but we can't reuse it. So we custom order those on a pallet, those sheets of plastic, and you can get them with varying layers that they're extruded in. So we have the plastic that we have is shiny on the live surface. So it's like a ultra gloss finish, which I can't remember if it actually has a layer of clear on it or not. Yeah, so down the road maybe we'll experiment with different ones, but we wanted to get something that didn't leave like an orange peel or wrinkled finish on the surface so that a customer could easily send these panels or his car to a body shop and they could still block sand everything and get it like show car worthy.
Totally.
Pretty
Yeah,
much.
I didn't mean to imply that it wasn't good looking. I mean, it's a
Yeah, yeah,
very
no,
good
no, no.
looking. It's just that's not the primary concern. Is
Right,
making it
for sure.
something that you can beat up and still be happy with.
Definitely,
Yeah.
definitely. Yeah, and if you see any of the cars that our customers run, and almost every single one is beat up at some point. It's got tire rub marks all over it or something, or cracked fenders or cracked bumpers. But yeah, so getting into the thermal forming is a crazy thing. I mean, not knowing anything about it or having somebody show you the ropes is there's a very unique like science to that whole process. And the way the elements work in our oven is we have what was it? We have 6 zones. So we have the working envelope is I think the machine's like a 10 by 10 machine, but so the back side of it is the oven. The front side is the actuators and your mold going up and down and the
Hmm.
drawer slide for the plastic. And we can fit like an 8 foot sheet by I think 4 foot sheet in there, or maybe 5 foot sheet in the machine. And then you put it into the slide, and then you slide it back into the oven. And the oven has so the 6 elements. There's 5 across the middle, and then 2 skinny strips, one in the front, one in the back. And you can control each zone on a Siemens controller that controls the machine, and we can apply different percentages to different zones based on what we're doing. And the thing that we're learning that is very difficult is the material around the frame that's being clamped does not get as hot as the center. The center just starts to get hot really fast and droop. But when
Right.
the corners aren't pliable enough and you try to draw apart, you'll get wrinkles, it stretches differently. And then taking this all back to like or going forward to trimming in the CNC machine, I'm trying to get the thermoform parts as consistent as possible. So how much time the plastic sheet is in the oven, that matters. The temperature, the exact zone temperatures of every element matters. All those things. The cooling time. Once it pulls out, we have fans that turn on and cool it while the plastic is stretched onto the mold. That has an effect to it. And then how fast you get to the dump valve and manually dump the vacuum. And right now we learned that our first few pulls that we need to adjust the vacuum ports on our mold because the vacuum draw is happening so slowly and the parts are cooling in that time, and we needed to like really like suck down much faster. So we need to open up some of the ports a little bit more and get more of the volume moving through there. But yeah, it's its own science, just as CNC machines are, man. I mean, you go down the rabbit hole and you start going into it's just like machinists chasing tolerances, right?
Right.
So
You guys, as a company, just seeming kind of to jump into the deep end on all of these things. You got the VR9, you got the welding robot, you got the vacuum forming. You guys are like, well, we'll just figure it out. Like, we're smart
yeah.
guys.
Yeah, exactly. And that is really what it comes down to. We do feel that way. We're just like, you know what? We're competent in some sense. So like, yeah, we can figure it out. I mean, we don't, even though we don't have somebody show us the ropes, there's plenty of people we could ask questions and whatnot, whether it's the manufacturers of the machines or someone that they might turn us on to that's doing something similar using the same machine or something like that. And yeah. And then going from a year ago, not having these machines in our shop to having this VR9 and then this massive thermoforming machine. Like we've really had to move things around the shop to make space for it, and we're definitely cramming our building. Our shop is about 5,000 square feet. It's a nice building and everything. It's nice. It was built in like the 70s, so power is a little
An
a little
issue.
on the low end. Yeah,
Yeah.
I mean we have we have 3-phase power, but we only have a 200 amp service. And when we ordered the thermoforming machine, I don't know if people have ever looked at, like any of the listeners have ever looked at what the draw is on thermoforming machines, but it kind of caught us off guard when we were looking, because the first machines that we had quoted out for what we were trying to do, I think they quoted us at like drawing 700 amps.
Ooh.
And that's double-sided ovens with dual elements, right? Like one on top, one on bottom.
Right.
So then we started narrowing it down. We're like, okay, well, we definitely don't have power for that. We're not going to get that much power to our buildings. What's the next thing we could do? So let's go to a single-sided oven. And then who can build a single-sided oven that's not 350 amps? And we ended up going with Bellovac for the thermoforming machine. And that machine draws 170 amps at 100% duty cycle. And we have a 200 amp service. So right now, currently, when we are using the thermoformer, nothing else is running. Like just the computers and stuff, but we're not running the Haas, we're not running the robot, we're not running any of the welders in the back of the shop, nothing like that. So and the other thing too is you're never really going to reach 100% duty cycle unless you are going to bake like a 1/2 inch piece of plastic ABS that's 8 feet by 4 feet or something like that. It's just never going to happen for us. We're dealing with materials that start out about like around 150 thou thick, 3/16 thick. I don't even think we haven't even gotten to like a 1/4 inch thick material yet. And really, you can just leave it in the oven longer. You don't need to bring it up to temperature very fast. You can just let it cook in the oven. It can just sit there for a longer period of time. Makes the process a little slower, but if that's what you got to deal with because you don't have enough power, then it is what it is.
Yeah, you got to do with what you got for sure.
Yeah.
So that jumps us into, I mean, you kind of already talked about shop news and new things, but are there any other new machines or new things on the horizon for you or Part Shop?
What's on the horizon? I mean, along with buying like the Haas and then buying the thermoformer, we had to get a new compressor just to run the thermoformer, just to run the actuators on there. So we went with the screw compressor for that, and kind of sucks because I wanted the screw compressor in the back of the shop to run the Haas, like the best air and everything over there on my end where I'm working. But the thermoformer needed an air compressor, and it's very close to the front office. It's in the front offices in our showroom. That's the only place we had to put it. So we used to have cars in our showroom. We pulled those out and we put the thermoformer in there. And then we, since we needed a compressor close to it, we obviously don't want to be deaf the whole time that thing's running. So we decided to go with the screw compressor that's on the other side of the wall in the shop area. And then nothing in the works right now for any new equipment. But if we kind of bring this into what have I been researching, then...
So let's finish it off. What have you been researching this week?
Yeah, so thermoforming techniques, obviously that's one of them, is looking at the temperatures, and there's different rules as far as what the corner temperature should be of the sheet and the material, things like that. Figuring that out. And then on the Haas side, when I go into work later today, I got to machine my first NPT thread with the thread mill. So that'll be interesting. I already drew it up in CAD and then programmed it in Fusion yesterday. And then I'm going to go ahead and run it on the machine today. And that's just so that on the bottom of our vacuum work holding for the 5-axis trimming in the machine, we have, instead of using something like a Pearson setup that uses a Venturi vacuum system, I talked to Jay over at Pearson Work Holding, and he recommended that I went with an actual vacuum pump and ran constant vacuum pressure, because he's like, when you're with the ABS process and putting parts in there, they might not be as repeatable as machine parts and stuff like that. So we don't have flat surfaces and everything on there. So he recommended that we would go with their like 1/4 inch gasket cord material, and then we just ran like an actual industrial like vacuum pump. So we ordered the same vacuum pump that we got on our thermal, just with, instead of having 8 tanks, we just have one little tank, and I'll be sitting on the back of behind the Haas machine, and we're going to plumb it through the enclosure inside there with a big 1.25 inch hose coming in, and then we'll have like an MPT elbow fitting on the bottom of the vacuum mold, and then the hose will just connect right into it. And we'll have a lever on the front of the machine that just dumps the valve or whatever, all the vacuum. So yeah, never did any kind of thread milling. I ordered our first single point thread mill from Mari Tool. It showed up. I just got to put it in a shrink fit and then try to do this MPT and see how it goes. And I got to say one thing is shout out to Saunders and the NYC CNC website. I mean, me being new to CNC, that website helped me so much as far as watching as many of his videos that I possibly could on my free time, and just him creating these like templates, like doing this MPT thread. I just went ahead and downloaded his calculator, this
Hmm.
Excel spreadsheet calculator, and that thing worked awesome. Hopefully it will. I mean, I'm sure it will, but I haven't done it yet. But plugging everything in there was just made it so easy for me and how to program everything. And then yeah, we'll see what kind of end result I get today.
Awesome. Well, hey, let me know how it goes, or post on your story or something. I'm looking forward to seeing how it all comes out. I'm sure it'll work perfectly.
Yeah, I definitely will. I'll definitely get on the Instagram side, making more actual posts rather than just stories. A lot of people miss the stories, so I just find it so hard being so busy all the time. That I find the time to sit down, edit photos and videos, and get it up
I
online.
I totally know the feeling. I think I posted on my Instagram as an actual post for the first time in like 8 months a few days ago. And I do stories from time to time, but it's just tough. Like you always want to make quality content, or at least not garbage content. But like I'm
Right,
okay just throwing up the random picture with like a little blurb on my story because it's no big deal. So I totally understand.
for sure, for sure.
Well,
Yeah,
Chris, again, I really appreciate you taking the time and coming on. Real quick before we close, a new Patreon. Thank you, Richard Watson. Thanks for joining the Patreon. Again, everybody, thank you for joining the Patreon. It really helps keep the podcast going and let me sub out what I need to make it all work. So thanks everyone for joining that. Thank you again, Chris, for coming on, and we'll see you all next week.
yeah. Dylan, thanks again for everything, and thanks for creating just a great platform for people to connect and learn. I mean, like I said, it helped me out so much prior to getting the CNC, being able to just listen to the podcast and listen to all these techniques or tools or tricks that you guys have learned over all the years and all the experience. And it just helped me out so much, man.
Oh, I really appreciate that. I mean, that's like the whole reason I love doing the podcast is to help people out. And so to hear that kind of feedback is amazing. I really appreciate that.
Awesome.
Well, thanks everyone for listening.